This is the stock price of NVIDIA. In the past 5 years, it has grown over 3,400%. And just this week, it has skyrocketed to become the most valuable company in the world. Here's a comparison with 3 other of the most valuable companies in the world. Red line is Apple, blue line is Microsoft, yellow line is Google, and green line is Nvidia. So you can see in 2020, Apple was over $2 trillion in market cap. Nvidia was around like 300 billion. And then 2021, both Microsoft and Apple had shot past 2 trillion in market cap. Nvidia still under 1 trillion. And then 2023, that's when this AI revolution really started gaining momentum. And you can see for the first time ever, Nvidia has shot past 1 trillion in market cap. But it was still quite behind Apple and Microsoft, which were approaching 3 trillion. But just this week, look at this insane growth. Nvidia shot past Microsoft and Apple, 2 of the biggest companies in the world, and is now the most valuable company in the world, with a market cap of $3.34 trillion. Now, some of you might think Nvidia is just a company that makes GPUs. Some of you might think Nvidia has plenty of other competitors doing the same thing, such as AMD and Intel. But here's why Nvidia is at a whole nother level, and why the closest competitors aren't even close. In this video, I'll go over the story of how Nvidia rose to dominance in this AI revolution, and why it became the world's most valuable company. Let's rewind back in time to the early 2010s. This is when neural networks started gaining popularity, and people started seeing its potential in being used for AI and machine learning. You see, traditional software programs are written with explicit instructions and rules. For example, a program could take an input and add 1 to it. However, neural networks operate differently. Instead of being programmed with a formula or set of rules, it's trained on desired results and learns the pattern by itself. If you're interested in learning more about how neural networks work, I highly recommend you watch this video. Anyways, this approach, inspired by the workings of the human brain, allows neural networks to learn patterns and relationships from vast amounts of data. One of the key breakthroughs that inspired Jensen Huang, CEO of NVIDIA, was AlexNet. This is a deep convolutional neural network that achieved groundbreaking results in a computer vision challenge in 2012. AlexNet achieved a top 5 error rate of 15.3%, which is a massive improvement over the previous best result of 26.2% by the runner-up. This demonstrated that deep convolutional neural networks could outperform traditional computer vision techniques by a large margin on challenging image datasets. Recognizing the transformative potential of neural networks and deep learning, NVIDIA made a strategic decision to bet big on AI computing hardware and software. Training and running neural networks requires a lot of data, a lot of compute, and they recognized that this would require specialized hardware and software solutions. Now, at that time, NVIDIA was mostly building GPUs which were designed for rendering graphics. These were mostly used for animations and video games. Well, it turns out that GPUs weren't only great for rendering graphics, but they could also be highly effective for accelerating the parallel computations required by neural networks. So, recognizing the potential of neural networks and AI in the coming decades, the company doubled down on developing GPU, hardware, and software ecosystems optimized for AI workloads. This includes the CUDA platform for parallel computing, which we'll go over in a sec. NVIDIA's early investment in AI computing hardware and software positioned the company at the forefront of the AI revolution. In 2016, Jensen delivered the world's first AI supercomputer, called the DGX-1, to OpenAI and Elon Musk. This groundbreaking supercomputer was specifically designed for AI workloads. It took NVIDIA around 5 years to develop and contained over 35,000 components. Jensen personally inscribed the DGX-1 with a message to Musk and the OpenAI team, highlighting its significance for the future of computing and humanity. Interestingly, earlier this year, when NVIDIA announced the crazy Blackwell superchip, which I'll go over in a sec, Jensen also personally delivered the first one to OpenAI with a signed message. Now, just a quick history on OpenAI. Sam Altman, along with Elon Musk and several other co-founders, started OpenAI out of concern that major tech companies, especially Google, would monopolize AI talent and resources. So Jensen's decision to provide OpenAI with the cutting-edge DGX-1 supercomputer aligned with his belief that it was quote-unquote incredibly appropriate for the world's first AI supercomputer to go to an organization focused on open and accessible AI research. Well, boy oh boy, how things have changed. As we all know, Elon Musk has since left the company and OpenAI has turned into, well, closed AI. Not only that, but very recently, they've hired former director of the National Security Agency, which of course is a highly controversial move. So it doesn't get more ironic than that. OpenAI is right now far from open or accessible to everyone. But back to NVIDIA's story. The DGX-1 accelerated OpenAI's research experiments tremendously. This enabled them to do new things that were previously not possible due to computational limits. It laid the groundwork for OpenAI's pioneering work in large language models, the technology that would later power ChatGPT and other generative AI tools. NVIDIA recognized the transformative potential of AI early on. They realized that it would change the way computing, software, and applications were developed. So Jensen's decision to provide OpenAI with the DGX-1 supercomputer was a pivotal moment in the AI revolution, enabling groundbreaking research and paving the way for current advancements in AI. Now, hardware is only one piece of the puzzle. Next, let's talk about their software ecosystem. A huge part of this ecosystem is their Compute Unified Device Architecture, otherwise known as CUDA. This is probably NVIDIA's biggest competitive edge against other companies, and this is what makes NVIDIA thrive in this AI revolution. Now, NVIDIA introduced CUDA way back in 2006 as the first general-purpose parallel computing platform and programming model. CUDA enabled developers to utilize the power of GPUs for general-purpose computing, and not just graphics rendering for video games. This early introduction allowed NVIDIA to establish CUDA as the industry standard for GPU programming. This gave NVIDIA a first-mover advantage that competitors have struggled to overcome, even to this day. Keep in mind, this was in 2006, way before AI became a mainstream thing. CUDA was originally introduced to use GPUs to do things beyond graphics rendering, but as neural networks and AI got more and more mainstream, CUDA has become the industry standard computing platform for AI, with all major AI models like Llama, Claude, and GPT-4 being trained on it. And many of the free and open source AI tools that we've covered on this channel, such as WOCADA, retrieval-based voice conversion, and TuneCrafter, also require a CUDA GPU to run well. All these tools were likely built on this CUDA platform. NVIDIA has built a huge and comprehensive software stack around CUDA, including libraries, tools, and APIs optimized for their GPUs. This includes cuBLAS for linear algebra, cuDNN for deep neural networks, and many more. This comprehensive set of tools and libraries makes CUDA a one-stop solution for GPU computing and training large AI models. Not only that, but many popular applications and frameworks for AI and machine learning, such as TensorFlow and PyTorch, offer optimized CUDA support. This further reinforces its position as the go-to platform for AI computing. And this ecosystem has attracted a large and active community of developers, researchers, and companies who have invested a lot of time and resources into learning and developing with CUDA. This creates a network effect where the value of CUDA increases as more people use it, making it difficult for competitors to lure these developers away. Plus, these researchers and companies have invested so much time and effort into building with CUDA, they're likely not going to leave CUDA and try a competitor ecosystem where they might need to reprogram and redo a lot of things from scratch. Now, that's not to say competitors don't have their own GPU computing ecosystem. For example, AMD has Radeon Open Compute, also known as ROCm, and Intel has OneAPI. But they've developed these much later than NVIDIA's CUDA, so they haven't achieved the same level of adoption or maturity as CUDA. They're simply behind because they weren't the first to do this. And now they need to play catch-up with NVIDIA's well-established CUDA ecosystem. It's really hard to overcome NVIDIA's head start and convince users to switch to AMD or Intel when they already are heavily invested in CUDA. And here's another reason why CUDA is so crucial to NVIDIA's success. CUDA is specifically optimized for NVIDIA GPUs, providing performance advantages that are hard for competitors to replicate. This deep integration allows developers to achieve higher performance and efficiency on NVIDIA hardware, making it a preferred choice for high-performance computing, such as for AI or machine learning. And although the AI boom is what really caused NVIDIA's value to skyrocket in the recent months, CUDA's adoption is not only limited to the world of AI and machine learning. Again, CUDA is designed for general-purpose computing, so it can also be applied to other industries like scientific research and financial modeling. Another cool thing about CUDA is that it's backward compatible with NVIDIA's GPUs. This ensures that software developed today will continue to run on future NVIDIA hardware. This long-term compatibility gives developers more confidence in their investment in the CUDA ecosystem, again reducing the likelihood of them switching to a competitor's platform. So all in all, CUDA is a huge moat for NVIDIA because it represents a deeply entrenched, highly optimized, and widely adopted platform for GPU computing, which of course is essential for AI and machine learning. This makes it very challenging for competitors to attract users away from NVIDIA. But it's not just software and their CUDA ecosystem that gives NVIDIA a competitive edge. And this brings us to their networking and interconnect technologies. As we know, NVIDIA GPUs are very powerful, but even the best GPU by itself is not enough to train a large state-of-the-art AI model. We need to connect hundreds to thousands to potentially millions of GPUs working together seamlessly in order to have enough compute to train the best AI models out there. And that's where interconnect technologies come in. These technologies basically link the compute power of multiple GPUs together so that you can scale up your compute seamlessly. These interconnect technologies are critical for scaling AI workloads across multiple GPUs and systems. That's because AI workloads require massive amounts of data to be transferred between GPUs and systems at extremely high speeds. And that's where NVLink and InfiniBand come in. They provide ultra-low latency and high bandwidth interconnects, enabling efficient scaling of these workloads across multiple GPUs and servers. Basically, these technologies enable very efficient data transfer and communication, allowing NVIDIA to build some of the world's fastest supercomputers like the GB200. Now, NVLink and InfiniBand are proprietary technologies developed and controlled by NVIDIA. Competitors cannot easily replicate or integrate these technologies into their solutions, giving NVIDIA a unique advantage in building high-performance, scalable systems for AI. And while competitors like AMD and Intel are working on their own interconnect solutions, again, NVIDIA has a head start. The widespread adoption of their computing technologies in AI gives them a huge moat. Similar to how a lot of customers are already building things using the CUDA ecosystem, many companies and developers have already invested in optimizing their applications and workflows with NVIDIA's interconnect technologies. Switching to alternative solutions would require a lot of effort and cost, and this creates a huge barrier to entry for competitors. Let me tell you about this awesome AI assistant called ChatLLM by our sponsor Abacus AI. You can try it for free via the link in the description below. ChatLLM is an awesome way to use different LLMs all in one place. This includes the newest GPT-4o, Meta's Llama 3, Anthropic's Claude Opus, and more. Not only can you chat with it like a regular chatbot, but it also retrieves the latest data from the web, ensuring that your output is the most up-to-date. You can also get these LLMs to generate images for you, right in the chat, so there's no need to head to a separate image generation platform. You can also create custom AI agents designed to perform specific tasks, whether it's automating customer support, generating reports, or any other function. your custom AI agent will handle it with precision. And collaboration is made easy with ChatLLM. You can invite team members to join the same chat thread, ensuring everyone is on the same page and can contribute to the chat. Moreover, ChatLLM integrates seamlessly with various enterprise platforms such as Slack, Teams, and more, so you can incorporate AI into your existing workflows without any hassle. Experience the power and versatility of ChatLLM by Abacus AI today. Try it for free via the link in the description below. Now back to the video. Finally, let's talk about their most cutting-edge hardware. In 2022, they released the Hopper GPU architecture designed for data centers and cloud computing. It features a new core design, improved memory hierarchy, and enhanced tensor core units, enabling faster and more efficient processing of AI workloads. And in the past few years, this Hopper chip has been the most demanded commodity in the tech world. As the AI revolution started to pick up momentum, companies quickly realized that the main bottleneck was compute. The more compute you have, the better AI models you could build, and the better AI talent you could attract. Whether it's for LLMs or image generation or video generation or anything, the more compute you have, the more ahead you'll be in this AI race. So obviously the tech giants, the companies with the most money, they'll try to get their hands on the best compute in the world, which at that time was these Hopper chips from NVIDIA. So these chips were pretty much sold out into early 2024, and the biggest tech giants have just been stockpiling them, as you can see in this chart. So for example, Microsoft and Meta were estimated to purchase around 150,000 H100s by end of last year. And then Amazon and Google also ordered a ton, but these two companies are actually designing their own computing units in-house. So for example, Google has their own tensor processing units, and that might explain why they haven't shipped as much H100s as Meta and Microsoft. And if you were a smaller company with little to no capital, there would be no chance in hell you could even get your hands on one of these, because they would just all be bought up by the tech giants already. But even something as demanded as the Hopper chip is history now, because earlier this year, NVIDIA announced a new ecosystem called Blackwell, and their signature chip is called the Grace Blackwell 200 Superchip. This is a groundbreaking state-of-the-art chip for several reasons. As you can see from this picture, the Blackwell GPU has a new design, consisting of two separate 104 billion transistor chiplets interconnected with a high-speed 10 tetrabyte per second link. This allows combining two of the largest possible chips into one package while maintaining high bandwidth and coherency between them. Together, this packs a crazy 208 billion transistors, making it the largest and most complex chip ever produced. This massive transistor count enables unprecedented levels of parallel processing power for AI workloads. And if this isn't crazy enough, this GB200 Grace Blackwell Superchip contains two of these GPUs with an ARM-based Grace CPU over NVLink, which we talked about before. This provides 900 gigabytes per second of bidirectional bandwidth and a unified memory space. This tight coupling of CPU and GPU enables very efficient processing for AI workloads. But even this Grace Blackwell Superchip is not good enough for intense AI workloads, so they introduced a scalable architecture. Here is the GB200 compute tray. So one tray has two of these superchips, which I showed you in the previous photo. And then one tray can be inserted into here. This is called the NVL72. This can scale up to 72 Blackwell GPUs, or basically 36 of these trays. All right, so you just insert 36 of these into this machine, and using NVLink switches, which again is this seamless interconnect technology that we mentioned previously, this essentially creates a single virtual GPU with 1.4 exaflops of AI performance. This scalability allows tackling the largest AI models and workloads. NVIDIA claims that the GP200 delivers 30 times higher inference performance and 25 times better efficiency compared with the previous Hopper GPUs. Remember, this Hopper GPU was the most demanded commodity in the tech world and is already state-of-the-art, at least before Blackwell came out. But to make something that's 30 times better performance in just 2 years is just an insane improvement. This performance leap enables real-time inference on models with over 1 trillion parameters. Now, that's not to say competitors haven't developed their own better and better chips for compute. So for example, AMD has launched its MI300 series, and Intel has launched its Gaudi 3 AI chips. But remember, this all goes back to NVIDIA being the first in this AI space. They created CUDA, and AI researchers and companies built their applications with CUDA, so they are very unlikely to switch over to AMD or another competitor because they've already built everything on top of NVIDIA. And this brings us to the insane ecosystem and level of partnerships that NVIDIA has right now. And the announcement of Blackwell further reinforces NVIDIA's dominance in AI computing. Major cloud providers and tech giants like Microsoft, Google, Amazon, and OpenAI have already announced integrating Blackwell into their cloud services, creating a strong ecosystem lock-in effect. Partnerships with industry leaders ensure widespread adoption and further development of Blackwell-optimized AI solutions. So with all these factors combined, this makes NVIDIA the undisputable champion in terms of AI computing. And because they were so early in the game by building CUDA, they've created a huge network effect which gives them a massive moat. Competitors are really going to have a hard time getting NVIDIA customers to switch over. And because AI is so hot right now, and it seems that compute is still one of the main bottlenecks, all the tech giants are just scrambling to get their hands on more and more compute. And so this has caused NVIDIA's market cap to skyrocket to become the world's most valuable company. Let me know in the comments what you think of NVIDIA. Do you think it will continue going up? Do you own any stocks of NVIDIA? And if so, what price did you buy it at? What do you think of other competitors like AMD and Intel? Do you think they stand a chance at potentially overtaking NVIDIA in the future? And what about chip companies that are more optimized for AI, like Grok, or neuromorphic chip companies like Rain? If AI compute evolves in the direction of neuromorphic computing, do you think this could erode NVIDIA's dominance in the future? Let me know in the comments below. As always, if you enjoyed this video, remember to like, share, subscribe, and stay tuned for more content. Also, we built a site where you can find all the AI tools out there for whatever your needs. You can also look for jobs in AI, machine learning, data science, and more. Check it out at ai-search.io. Thanks for watching, and I'll see you in the next one.